is Mr. Mladen Stojic. Am I right? Okay. Mladen is with over 50 years of combined experience across the Hexagon companies. And Stojic holds a Bachelor of Technology degree from Ryerson Polytechnic University in Toronto and a Master of Science from the University of Western Ontario in London. The floor is yours.
Thank you. Good afternoon. My name is Mladen Stojic. I'm with Intergraph Corporation, that's part of Hexagon, and I have the pleasure of working with a great group of individuals around the world when it comes to building geospatial technology products and ultimately solutions that are deployed around the world. For today's presentation, I'm going to focus on understanding some of the trends, perhaps giving you a different perspective, and also talk about some of the best practices, some of the things that we have customers in Brazil doing today, and some of the technology practices that are being implemented around the world. The first thing I want to say, and the first thing I want to start with is talk a little bit about change, because it's change, and specifically geographic change, that impacts our world and really impacts the business that we're in. If things stopped changing around the world, we wouldn't be here. We would not be creating new maps. We would not be deploying and dispatching ambulance crews or police officers or field units out to assess the utility system and so forth. It's change around our world, whether it's natural change, man-made change. It's really this change that's impacting what we do. And things are changing at a rapid pace, and like I said, we have natural disasters, we have urban sprawl, we have environmental effects occurring every day, we have wind energy and global change in terms of climate change and so forth. But it's the change, and specifically the geographic change, that it's our job to build the technology and the capabilities required to understand that change, but more importantly, to transform information about that change into information so that you and our customers and the industry can make smarter decisions and really take action. So I want to talk a little bit about change and what we're doing in order to understand change, and I want to start with a human sort of example. And we live in a beautiful world, and as human beings, we have the ability to perceive change around us. We have 5 senses. We have the ability to see. We have the ability to touch. We have the ability to smell something. We have the ability to taste. And we have the ability to hear. So as human beings, we are sensors, and we have senses. And our senses provide our perception the ability to basically organize, identify, and disseminate information so that we can take action, make decisions, and really move forward. So as human beings, we have the ability to sense the world around us. We have a brain that processes this information, and as human beings, we have the ability to act. If we take that analogy and that concept of change and our ability as human beings to understand change, how can we translate that to our business? How can we translate that to our industry and implement solutions that ultimately shorten the life cycle required to sense digitally, but ultimately transform information so that we can act, so we can make decisions and ultimately move forward? A nice example, and folks, there are many of these around the world. I just chose this one because I was involved in this project along the western coast of Oregon, along specifically a coastal area that experienced a lot of rain. And the rain impacted landslides, and massive landslides. We had a loss of property, loss of lives, and really a lot of bad things happened as a result of this type of change. And typically the first thing that happens is you start sensing, and we have these new trends of sensing the Earth in a fast way, in an easy-to-deploy way through these radio-controlled UAVs these days, right? So we have many UAVs that are now exploding into the market that we can deploy, we can control with the radio, and ultimately derive data. It's not information yet, it's just raw data, pixels, some airborne GPS information, but ultimately what we need in order to produce base content that can be used to ultimately process that data and ultimately produce information that can be used to provide early responders, police forces, ambulance, emergency, and so forth, what they need in order to respond. This all sounds very good, and we're moving in the right direction. So the industry is certainly moving forward when it comes to being able to synthesize multiple sources of content, fuse those with multiple sensing and software technologies to ultimately extract information. But it's hard. It's difficult. It's not as easy as it really needs to be. And Hexagons Vision, and specifically Intergraph's vision, is to build the software solutions required to shorten how long it takes to capture something and ultimately turn it into information from the sensors we have. But we have challenges. And we've heard a lot about these buzzwords. If you read The Economist, if you read Harvard Business Review, if you read many of the journals in Brazil or outside the world, big data, we hear a lot about big data, okay? But when we talk about big data, we're talking about terabytes, petabytes of content, raster content, feature content, other content that gets merged and really fused with base data. The geospatial industry deals with big data on a daily basis. But it's not just a matter of understanding which data you have and understanding what's out there, what's inside your organization, or perhaps what's outside your organization. You have to be able to analyze that content, fuse it with multiple sources of information and data, and ultimately derive some information. And when we talk about analytics, I think we've made the mistake of associating analytics simply with geoprocessing or spatial modeling or spatial analysis. But analytics has two sides to the coin. And when we talk about analytics, we cannot separate geoprocessing, spatial modeling, and analysis with communication. It gives us no good value to simply run a spatial model or do some analysis. A hotspot is something simple as a hotspot or a buffer to assess where you can run a suitability analysis for placing a store or a building or a school and so forth. We have to be able to disseminate the data from that process and communicate it in such a way that is context specific to the industries that we cater and serve to. Whether it be the farmer, whether it be the urban planner, whether it be the public works engineer for a city council. We have failed in our ability to communicate effective information to the people who need it in the field and in the office. These are not people that have a geospatial background. These are individuals who understand their business, and we have to do a better job of communicating the great capabilities that allow us to derive information from geospatial content and deliver it in such a way that it makes sense. Because at the moment, we do not make sense. And our job is to build systems that make sense, not only to sense the Earth, but build the capabilities that allow you to make sense in order to do your job. A farmer who has machine control systems, who has the ability to understand where to fertilize, when to water, when to harvest a crop and so forth. A farmer has a dashboard that they're looking at information that helps them guide the tractor and know where to plant, know where to harvest and so forth. A farmer doesn't necessarily want to look at all of the capabilities available in desktop systems, in these sophisticated technologies we have. A farmer wants to know the line they have to travel down with the GPS, where to drop, where to pull, where to harvest, where to water, where to seed, and so forth. So we have to be able to integrate with other systems and deliver information that are context-specific to the industries that we cater to today. We've been in this business for a long time. The geospatial industry, if you really want to take a perspective, started back even before Ptolemy, but we started making maps. We have records of Ptolemy and its map making required to provide kingdoms the ability to navigate and support trading and so forth. But you can see a geospatial progression that we've been on for the last many centuries, but over the last 40 years, 4 decades, we've seen an explosion in the digital ability to understand our Earth with the emergence of GIS, with the emergence of remote sensing, photogrammetry software systems, and so forth. These are all geospatial genres that in and of themselves are very powerful, but they have created a silo effect in many organizations that unfortunately now do not have the ability to share and utilize the wealth of content and information available inside their agency. It's our job to basically fuse these genres together with sensors, because if you can't sense the Earth, if you can't capture what's happening, and then transform that to information with tight software solutions, you have the ability of not being able to extract the information required. And I urge and stress the importance of being tightly connected to a sensor, because a sensor captures a lot of metadata. And it's the metadata that is the language required that basically allows us to extract even more from content than simply points, lines, polygons, pixels, point clouds, and so forth. There has to be a tight connection between metadata, between the sensor and the software, and metadata is that common language. Metadata is that thing that ties the sensor to the software so you can do more with the data. As part of Hexagon, our vision is to take sensors, add software, and build specific solutions for a variety of different industries. So we cannot separate the sensor from the software. And understanding the industry and understanding the context and how users want to communicate, we have the ability to build intelligent systems that will make a difference in our world. How does this happen? Once again, change is the spark. If I can use a car analogy, change is the spark that ignites the fuel. The fuel is the data. The fuel is the content. The fuel is what comes off a satellite, what comes off an airborne system, what comes off a TPS, GPS system, that comes off a mobile mapping system, that comes off a GPS system. That's the fuel. And many organizations have fuel, but the fuel's not being ignited and the fuel's not being used to accelerate a capability or a solution or perhaps a workflow inside these organizations. And we have systems that allow us to take the sensing data with the metadata, manage that content, process it, share it, and ultimately deliver it as solutions that make sense in the various industries that we work with today. And it really involves synthesizing these core geospatial genres. If we use the genre analogy with music, the ability to fuse different genres together into these engines to deliver things that make sense in a way that makes sense, whether it's through interactive maps, lightweight mobile apps, and so forth. So these are new trends that we're seeing implemented day in and day out. And ultimately, our goal is to simplify these offerings so that we empower many more people around the world to leverage the power and ultimately the strength of geospatial technology. Let's talk about a couple of examples. In agriculture, I showed a previous slide with a farmer who has a mobile device inside the tractor with a machine control system, with GPS, but a farmer wants to be able to take data from multiple sources, fuse those sources, and ultimately extract information that will help optimize the resources they have on the farm, optimize the equipment that they have to work with, and really make sense in terms of how to take what you have to do on a day-to-day basis and really understand how to fertilize, where to water, when to water, and ultimately the goal is to increase productivity. In this day and age with population growth, it's very important, especially with the landscape and the weather systems changing dramatically, it's very important to build smart systems, smart agriculture systems that leverage multiple sources of data that ultimately provide value to a farmer in the field. If we look at transportation networks and infrastructure projects, whether it's building new corridors or basically maintaining existing corridors, the same idea applies. We have the ability to take data from photogrammetric aerial cameras to satellite sensors to UAV sensors, and now with mobile mapping where you can drive with a car and record point clouds, we have the ability to fuse all this content together, but ultimately it has to be turned into information to support asset management, asset inventory connected with mobile devices so that field workers in the field know what to do, know where to dig, know where to address issues as they relate to street furniture on a transportation corridor. There's been a lot of talk about smart cities, okay? Smart cities have the ingredients to be smart. And when we talk about what it means to be smart, Smart means taking software with multiple sources of data and ultimately deliver information solutions that update themselves. Where you have the sensors basically continually providing dynamic feeds and creating smart maps. Smart maps that are connected. Smart maps that are operational and portable in the field. Smart maps that update themselves. We're not talking about file-based systems, we're talking about mobile systems that are connected to the various IT infrastructure available inside of cities, where once again we can take data and IT systems and merge those together in order to provide the information, whether it be for public works, whether it be for public safety, whether it be for transportation, urban planning, economic development, and so forth. So smart cities is a vision that's very possible, but it requires connecting the various systems available, whether it be sensing systems, IT systems, adding some software with an industry know-how together in order to deliver solutions that make sense in the space. Thank you. Mining is the last area I'll talk about, and once again, if you look at a mine, this is not a new industry. The area of mining has gone on for a very long time. But we're now moving towards smart mines, dynamic mines, live mines, where we have job sites, connected, networked job sites, where we have UAVs flying, collecting data, processing it, using semi-global matching to extract accurate point clouds, doing change detection, understanding volumetric changes, ultimately fusing multiple data sources together to help facilitate a connected, a dynamic, and really a live mine. Because you have workers in the field, you have tractors pushing and moving dirt and rocks, and you have to have the ability to understand what's happening with one common operational picture inside of a mine. Here we see a great fusion of sensors, GPS sensors, with UAV sensors, with software connected with desktop server systems and mobile devices to really provide that common operational picture inside of a mine. I want to finish with focusing on best practices, both from a customer perspective, but also from some of the things that we're seeing in the technology sphere of influence. And I'll focus largely on Brazil. We have some great examples in the country of Brazil. For example, CMIG, which is a power distribution organization, and they're using great systems and solutions today to basically understand and find and really edit and update geospatial services inside that organization, supporting regional offices and local users who have the ability to see what's there, get it, and ultimately use it for their application. And this is not only for imagery, but also for feature data sets. They have the ability to customize unique workflows, smart workflows that know how to grab the data, that recognize the role and the privileges required for a given user, and fuse that data with the software nugget required in order to execute a workflow. So we have some great examples in Brazil that are effectively using these smart systems today. Moving to Petrobras, another great example inside the country of Brazil, where oil and gas solutions were deployed to centrally maintain and update geographic changes over 14 specific refineries inside the country of Brazil. And using smart systems, they have the ability to pull geospatial data layers, fuse those with software, and ultimately deliver workflows that make sense to their users. Looking at IBGE, focused on topographic mapping and the census, supporting more than 100 users working together to update GIS layers that can be used by other individuals, both in government and the private sector, to basically have a view of what's happening from a demographic perspective. And these are not only web systems, but also desktop systems that allow you to do the heavy lifting, authoring, and update of those geospatial data layers inside their organization. The last example is CET, which is a transportation engineering solution required to basically understand the changes occurring with respect to accidents, with respect to lights not working, and the ability to synthesize all of those inputs into a central system that can ultimately be deployed in the field, supporting more than 500 users who have the ability to support bi-directional communication, the ability to consume, but also the ability to push back data and changes as they occur. So you have a live traffic system that is continually updated, giving you a precise reference of what's going on inside a city. Talking a little bit about technology best practices, we just finished a very big project supporting RWE, which is a very big utilities company in Germany. They had the responsibility of supporting field operations, and we started with synthesizing a very large collection of raster data. over 38 terabytes of raster content at 20 centimeters resolution. And when we talk about big data, that's big data. We had to compress that data, manage it, and ultimately serve it to many users inside of RWE and outside RWE over a low bandwidth pipe. And that has to support both Android and iOS systems. So using something called ECW, we have the ability to compress the data, fuse the content, and ultimately stream that data to mobile devices, both Android and iOS devices. We talked about analytics, and we come from a world where you have the raster view of modeling, you have the vector view of modeling, now we have point cloud operators and a different sort of mix and breed of spatial capability. We're seeing fusion when it comes to fusing raster, feature, point cloud data coming together with an analytics engine that allows you to look at dynamic updates as things change and as variables change inside a given model, but also allow you to publish that model so people using mobile and web clients can consume the results of that as an information service. Crowdsourcing is another practice and a trend that we're seeing a lot of, where we have government agencies deploying mobile apps that allow the general public, citizens, to walk around and ultimately sense events, incidents. If you see a pothole, if you see a broken light, if you see something that the government needs to know about, you take a picture with your device, it's geocoded, you attribute it, and basically publish it to the city council, and then they have a view of what's going on inside of that geopolitical boundary. So we're seeing crowdsourcing and the fusion of mobile technologies, leveraging the cloud as an infrastructure to enable sharing of that data as a practice around the world already. And when we talk about mobile, we're not just talking about crowdsourcing, but we're also seeing a huge explosion when it comes to field inspection, being able to extend what you do in the office in the field in a connected manner so that you can update attribution, update your feature geometries as things change, and upload those back to a central repository that can ultimately be used by other key stakeholders. So I want you to think about change, and I want you to think about how we as an industry and as a group of individuals have the ability to transform what's happening outside in the world, leveraging sensors with software, combining and fusing those two together in order to build solutions that ultimately help us understand the change around us. Thank you very much.